Hey guys, how are you doing? So here we have a question on electricity and magnetism, specifically the magnetism part, one of my favorites. Let's have a read at the question. So two long straight wires were hanging parallel to each other and are 1 centimeter apart. If you notice, the length of the wires are not given. We will not care. So we will write two parallel wires like this, which are exactly 1 centimeter apart. 1 centimeter apart. The current in wire 1 is 5 ampere. Let's call this wire 1. This is 5 ampere. And the current in wire 2 is 10 ampere. In the same direction. Very important. Which of the following best describes the magnetic force per unit length? Basically F by L. Now, here's an interesting derivation that I will help us write. And using this derivation, we can write down the understanding or the statement which correlates to the question statement given. Now, remember this, a current carrying wire is capable of producing a magnetic field. So let's say that this is I1 current, this is current I2. I1 is capable of producing a magnetic field B1, which will be applied on I2 because I1 can't apply a magnetic field on itself. So I1 will produce a magnetic field B1 around itself, which will be applied on I2. Similarly, I2 will produce a magnetic field B2, which will obviously be applied on I1. We know that force acting F is equal to BIL sine theta. We'll ignore the sine theta, assuming that they are perpendicular. So F equals BIL. So to be specific, force applied by current 1 on current 2 is equal to the magnetic field produced by current 1 into the current of I2 into the length. We know length is infinite, so we'll make some adjustment for that. So we know by logic that F12 will be equal to F21, albeit in the negative direction. This is basically attraction. So the two wires, let's say this is F12, this is F21. The two wires will attract each other with a force that is equal to this. So going to the next step, I can write F, since F12 is F21, I'll just write it as F in general. So F by L, the formula, force per unit length, is equal to V1 into I2. And we know this. We know that magnetic field due to an infinitely long straight conductor is mu naught by 4 pi 2 I1 divided by R into I2. So this gives us the combined equation mu naught by 2 pi I1 I2 by R. Here I1 refers to the current in the first wire, which is 5 amperes. I2 refers to the second wire, that is 10 amperes. R refers to the distance between them. Please make sure to take SI units, 0.01 meters. And mu naught is permeability of free space, which is 4 pi into 10 to the power of -7. I think the units are Tesla meter per ampere. Yes. Okay, fine. Anyway, the units don't matter. So these are the substitutions. With these substitutions, we will find out that the force per unit length is exactly equal to 0.01 newtons per meter. And I told you this, since the two wires are attracting each other, the only statement which makes sense is option D, which says that the force per unit length on wire 1 is 0.001 Newton per meter, and it is acting towards wire 2. So we notice that it is acting towards because the two wires are attracting, not repelling. In fact, if you guys are interested, you can look at the SI definition of ampere. SI definition of 1 ampere. The SI definition of 1 ampere is in fact derived using this particular formula. F by L is equal to mu naught by 2 pi I1 I2 by R. Have a great day, guys.